Well, let's take all the information that you guys have pulled together so far and let's just make sure we're all on the same page here, because there is, hopefully, as you have found, a little bit of a shortcut when you're trying to come up with your rule for a function. So let's tie up all these loose ends and get everybody understanding what those shortcuts are. So let's take, for example, I have an input-output table. I have my inputs labeled X, my outputs labeled Y. And you can see my input values are 0, 1, 2, 3, and 4, and my outputs are -4, -1, 2, 5, and 8. So if the first thing you might look at is, what kind of patterns do you see? So really, we're kind of going back to what we did with our build-a-patterns, which got us started on this. So if you look at your table, you can see on the left-hand side, our inputs, we're increasing by 1 every time. These just go up, +1, just get 1 bigger every single time. And then on our output side, we are adding 3 every time. So what you should have concluded from your functions packet was the fact that this 3 repeatedly shows up. We are repeatedly adding 3. If you remember from last week, we said repeated addition is really just multiplication. So that's a big clue when you're writing your rule. If this continues to go up by 3 while this is going up by 1, that's going to tell us a couple of things. First, it's going to tell us that we are going to have a linear function. And we know it's linear because it keeps the outputs continually increased by the same amount while the inputs are also increasing by the same amount. So while these go up by 1, these go up by 3. So I'm going to already know before I even graph it, this is going to be some sort of line, probably some diagonal slanted line. And we're going to get to the graphing in just a minute. But doing this part also tells me that that 3 is going to be useful to me in my rule. Whatever number we are repeatedly adding is going to be our coefficient. So we're going to go ahead and put that into our rule. So we're going to multiply that coefficient times our input. Now, we also figured out in our functions packet how to determine what the constant would be. The way we got our constant was by extending our graph until it hit the y-axis. So wherever our line hits this axis right here, that number is the constant. So if I know enough about my ordered pairs, I can already tell you where it's going to hit the y-axis. Any point on the y-axis will have an x-coordinate of 0. That means I'm not going to go over any at all. I'm going to stay right here on my origin. I'm either going to go straight up or straight down. So that means I'm looking for the value, the ordered pair in my table that has an x of 0. So if I look right here, the ordered pair is 0, -4. This is my y-intercept. It's called the y-intercept, and we'll talk more about that term later on. So if you don't remember it right now, that's okay. But this line is going to hit the y-axis at 0, -4. So when I graph it, that's over 0, and I go down to -4, right there. That number is my constant. And if it's not there, well, we will look for it. So that is the other part of my rule. So since it's a -4, I could either write just -4, or I could say y equals 3x plus a -4, like we did back in the good old days in the fall. Now, this rule, I could double check it and make sure it works. So let's try a couple values. If I plug in 1, I'm supposed to get out -1. So I'm going to plug in 1 for x. 3 times a 1 is 3, and then take away 4 from that gives me -1. So that works. If I put in 2, 3 times 2 is 6, -4 will give me +2. 3 times 3 is 9, -4 gives me 5. We're on a roll. Call us butter because we're on a roll. So that means I have the correct rule because it works for every single value. I didn't have to do any guessing. All I had to do was use the patterns and the relationships that I've already figured out and use them to my advantage and come up with this rule. Now let's go ahead and graph this. Let's finish off our points. We already did 0, -4. So now my next point was 1, -1, which is right here. 2, 2. 3, 5 is right here. And then 4, 8 will be up here. And then you can use your line and just go ahead and connect all of those nice and neat. And you see, it's a line, it's linear because it hits every single one of those points. Not a little bit off, they're all perfectly right through the middle. So there you go. That's how you can tell quickly whether it's linear or not, and how you can get your rule very, very, very quickly. All right, now, not everything is as neat and tidy as that first one, so let's take a look at another example. Let's suppose my input and output table looks like this. I have the values 2, 3, 5, and 6, and 3, 5, 9, 11. So first, let's just take a look at some patterns. We can see that this is going up by 2, and this goes up by 4, and this goes up by 2. Well, I say, oh no, it doesn't go up by the same amount every time, so it must not be linear. Before you draw that conclusion, you need to look at your input values. Look at what's happening over here. This is going up by 1. Then we go up by 2, we jump, and then we go up by 1 again. The fact that it goes 1, 2, 1, and 2, 4, 2, hopefully you're saying in your mind right now, Mrs. Rigler, this number is twice as much as that number every time. 2 is twice as much as 1. 4 is twice as much as 2. 2 is twice as much as 1. And then that, because there's a pattern there, might lead us to say, hey, we should take a little bit closer look at this. Well, look over here, your inputs. What number logically, what number are we missing in this right here? And hopefully you're saying right now that we are missing the number 4. If I put 4 in here and matched it up with an output, what would that output be? Based on the patterns that you see over here, what number would match up with an input of 4? Hopefully you're saying 7. Then, after we fill in all those values, let's go back and look and say, we go from 2 to 3 by adding 1. We go 3 to 4, add 1. 4 to 5, add 1. 5 to 6, add 1. These inputs are all going up by 1, and these outputs are all going up by 2. Aha! So what conclusion can you draw from that? Did you say it? I didn't hear you. Is it, let me narrow down your choices. Is this going to be linear or non-linear? Circle your screen right now. Linear or non-linear? And the answer is linear. This will be a line because your outputs are consistently going up by 2 while your inputs are going up by 1. So if we write our rule, we're going to have y equals, and since this is repeatedly adding 2, where does that fit into our rule? And I'm hoping you said, well, Mrs. Rigler, that's our coefficient, because you are correct. Our coefficient is going to be 2 because since repeated addition is the same as multiplication, it would make sense that we multiply our variable by 2. Now, if you remember, we figured out how to get the constant, if there is a constant. And the constant is where the graph hits the y-axis, also known as the y-intercept, if you forgot that word already. Y-intercept. Intercept means it hits or intersects the y-axis. Well, any point on the y-axis has to have an x value of 0. So what I want you to do is pause me right now, and I want you to figure out, based on this pattern, what number would match up with 0 if we filled in the rest of this table. So we had a 0 value on here. So what is our y-intercept? So fill that in on your own, come up with that number, and then unpause me once you figure it out. All right, so if we look at these patterns, what I'm missing is 0, and also I'm missing a 1. I don't have a 1 value here, so now it really does go up by 1 every single time, which is good, and that means these numbers have to go up by 2. Well, we kind of have to work backwards here. We're going from 11 to 9 to 7 to 5 to 3, and then we have to fill in these first 2 values. So as I go up the table, they're getting smaller by 2. From 11 to 9, I have to take away 2. 9 to 7, take away 2. 7 to 5, take away 2. 5 to 3, take away 2. So if I take away 2 from 3, that will tell me the number that matches up with my input of 1. So 3 minus 2 would be 1. And then if I want to know what number matches up with the 0, I just do it again. So 1 minus 2 will put me at -1. So this is my y-intercept and also the constant in my rule. So -1 is my constant. So I'm going to put that in as -1. Or, again, you can write it as y equals 2x plus -1. These are the same exact thing. And there you have it. So if you can identify whether it's linear or nonlinear based on your input-output table, and then also determine the rule that goes with it, this idea of using the pattern and the y-intercept will make your life so much easier, and you will come up with these rules extremely quickly. So, hopefully, you understand all of that. If you have any questions, let me know. And now you are pros at linear and nonlinear functions. So use that knowledge to help you out, and good luck. Bye-bye.